Good morning, and welcome to this EnviroMix webinar titled The Evolution of Compressed Gas Mixing. This is going to be the first in a series of webinars that we have planned for this year. I believe we have 5 or 6 scheduled. So we wanted to say thank you for joining us this morning. We appreciate the opportunity to speak with you. My name is Tyler Coons. I'm the Vice President of Sales with EnviroMix. A little bit of background, I've been in the industry for about 25 years. Have been in the business of process equipment sales my entire career. I've been with EnviroMix about the last 7 years. And we are based in Charleston, South Carolina. That's where our corporate headquarters is located. And then we also have a satellite office just north of Milwaukee, Wisconsin, where we have six people working as well. So we're anticipating about a 30-minute presentation this morning. That'll be enough to get through the content. And then, of course, we're planning for a Q&A session at the end. We have about 15 minutes allocated for that. If you do have questions, they can be submitted through the Q&A feature on the webinar platform here. It's on the left-hand side of your screen. So if you have questions along the way, just please click on that Q&A and then submit the questions through the platform. I'm going to turn off my web camera here for most of the presentation. I'll turn it back on at the end, and hopefully we have some good questions. And we certainly hope that you enjoy the content of the webinar this morning. So as mentioned, we're going to be discussing the evolution of compressed gas mixing and the agenda for this morning's presentation. We're going to start with a little bit of a review. So for those on the call this morning that may not be as familiar with compressed gas mixing, we'll go through a review of what the technology is, how it works, what applications it's most beneficial in. And then we'll talk about how the technology has evolved over the course of time that EnviroMix has been providing the BioMix Compressed Gas Mixing system. And then finally, we're going to finish up with some case studies where we'll discuss 3 separate facilities that have utilized BioMix Compressed Gas Mixing to help solve their unique challenges. And then finally, the Q&A session. So let's start out with a little bit of background on what is BioMix Compressed Gas Mixing and how does it work. So this is an illustration of the system, a very straightforward mixing system. And BioMix Compressed Gas Mixing is a mixing system where we will achieve very high efficiency, low maintenance mixing in a wide range of applications. And we achieve that mixing by firing short bursts of high pressure air intermittently and sequentially throughout the basin to produce clusters of large bubbles that will mix the tank from the bottom up. So we start with a rotary screw compressor that you see up here under the canopy. We generate clean, dry, high pressure air with a rotary screw compressor. We charge a receiver tank, which is just a pressure vessel and essentially serves as a reservoir to hold that high pressure air. That high pressure air is subsequently released in intermittent bursts into the tank through a valve module, where we control the releases of the bursts of air, and we control the mixing intensity through the adjustment of various parameters of firing, including the pressure we're firing the air at, the frequency, the duration, and the sequence. So in this example, you can see the high pressure air comes into the valve module, and then coming out of the valve module, you have 4 header supply pipes, which feed 4 individual headers at the bottom of the tank. So each of those headers is going to get a burst of air separately from the other headers. So you get this sequence of firing from the bottom of the tank, and when that burst of air is released through the valve module, it travels down the header supply pipe. It's going to simultaneously explode out of all 5 nozzles on that header. And when it does, that burst of air explodes out of all 4 sides of each nozzle, scours the floor in roughly a 3 to 4 foot radius around the nozzles, and produces clusters of large bubbles that then form into this large amorphous mass of air that continues to rise as it expands through the water column to induce both horizontal and vertical mixing velocities within the tank. It mixes the tank from the bottom up, so it's actually turning over the contents of the tank, versus a lot of traditional mixing technologies are stirring the tank. So you're getting a better degree of mixing with this type of a mixing system. Where do we get the efficiency? is through the uniform distribution of energy across the floor of the tank. And you can see that in this illustration. It's essentially a full floor coverage mixing system, which makes it inherently more efficient than a point source mixer. So in this same tank, if you're going to mix this with a traditional point source mechanical mixer, you'd likely have one device either in the corner or the center of the tank. You need to put in a lot more energy because you're putting all of the energy in one spot in the tank. So the BioMix Compressed Gas Mixing System will provide much more efficient mixing. Generally, we're going to be down in the range of about 0.1 horsepower per 1,000 cubic feet or less. So very high efficiency. This next slide here is a video clip of the system operating in a 6 MGD facility in Ohio. This is a B&R mixing application. So what you're seeing here in the video are 3 different anaerobic selector zones. You can see in the bottom left-hand corner of the screen, within each of these baffled zones, you have 3 nozzles, and you can see the typical sequence of these bursts of air, which is also operator adjustable. What's very notable in the video, and what we like to point out, is by the time the bubbles are breaking the surface, you can see that that mass of air, the masses of air from each nozzle, they've expanded to the point where there's an overlap in their zone of influence. So we're effectively hitting this entire cross-sectional area of each zone with mixing energy, which is what makes it so efficient. Despite the fact that we're using air to mix the tank, there is only a very negligible amount of oxygen transfer, essentially immeasurable oxygen transfer, and that has to do with the size of the bubbles that are being produced by the BioMix nozzles. Because of the size of the bubbles, there is a very low surface area of bubble within the volume of air we're introducing into the tank, which makes it ideal for both anoxic and anaerobic mixing environments. This next video is obviously a much larger scale. This is a 21 million gallon per day facility in Orlando, Florida. And you can see the typical sequencing of the air through the basin. In this video, you're getting a burst of air to an individual header roughly every 3 to 4 seconds. The flexibility of this system also allows unlimited turn down. You can adjust and dial back the mixing intensity. It's not just on or off. So you can actually adjust the mixing intensity to suit the instantaneous process needs of the basin that you're mixing. There's also flexibility to even vary the mixing intensity within different zones of the tank. So for instance, if you had an instance where maybe there was a convergence of flows or an area of the tank where you had some type of obstruction or a hydraulic challenge where maybe you wanted more mixing intensity, you can actually adjust spatially within the tank and have certain headers fire more frequently. So you can not only vary the overall mixing intensity, you can even vary the mixing intensity throughout the tank itself. Here's an image of a typical BioMix compressed gas mixing system. And I think the operative words here are comprehensive scope of supply, unit responsibility. It is furnished as a complete system that starts with all of the in-tank piping, nozzles, and anchors. This is going to be all stainless steel components, absolutely no moving parts, which is why the system requires no in-tank maintenance. The headers are factory fabricated, so all of the cutting, threading, welding, full immersion passivation, that's all done under very strict quality control conditions. And the system is delivered as an engineered system with a set of erection drawings for very easy installation by the installing contractor. We'll also furnish the valve modules and controls. And as we'll talk a little later in the presentation, we have a few different options and variations of the specific control strategy, depending on the size and complexity of the installation, receiver tanks, and then finally a high pressure air source. So Enviromix will size an appropriate high pressure air source, typically in the form of a rotary screw compressor to deliver clean, dry air that will meet the mixing needs of the system. And then most importantly, we offer comprehensive design support and a performance guarantee. People talk a lot about efficiency in our industry, and that applies to all different technologies, including mixing. And we think you need to take it to the next level, because having high efficiency doesn't mean much unless we define what adequate mixing is first. So in every one of our installations, we will guarantee uniform mixing, and we'll substantiate that uniformity in a witnessed field performance test where after the system is up and running, we'll come in and we'll document that we're achieving homogeneous contents throughout the tank as shown through 10% or less coefficient of variation within the tanks or zones we're mixing. The BioMix Compressed Gas Mixing system is suitable for a very wide range of applications that you might find at a typical wastewater treatment plant. That could start at the pump station or lift stations, breaking up grease or other solids that may accumulate at the top of those tanks. Equalization tanks are a great application. The system is very adept at accommodating highly variable water levels, which you often see in an EQ tank. And if that EQ tank is upstream of your activated sludge plant, where you may have anaerobic and anoxic selector zones, you're not adding a lot of residual DO in that tank. So you're not going to poison your selector zones that are very critical to the BNR process. Moving over to the activated sludge basins, there are opportunities, obviously, for selector zones. This would include anaerobic zones, anoxic zones, swing zones. If there are swing zones that can be run either in an aerobic or an anoxic mode, the BioMix compressed gas mixing system is very easily combined with either a fine or coarse bubble aeration system. It doesn't have that same damaging effect or potentially damaging effect on a PVC piping system that you oftentimes see with point source mixing. Moving on into the aeration basin, there are opportunities to decouple aeration from mixing, meaning providing biomix within the mixing limited portions of the aeration basin gives the operators the flexibility to independently control oxygen transfer versus mixing, which can not only save a lot of energy, but it also can help to improve the secondary process. Channel mixing is a great application, and we'll talk about a case study of a facility that's yielded significant benefits utilizing biomix in their channels, chlorine contact chambers. And then moving on to the solid side of things, biomix presents a lot of advantages in sludge storage. We've demonstrated mixing effectiveness as high as 6% solids. And then finally, digestion. Biomix can be applied for both anaerobic as well as aerobic digestion. And while the exact list of advantages varies by application, you're going to see general themes of reduced energy, reduced maintenance, and increased flexibility across all of these different type of applications where the technology can be applied. So I know that was a pretty quick overview, and hopefully it was helpful to anyone that's a little less familiar with BioMix compressed gas mixing. Obviously, if anyone's interested in learning more, we'd love to talk about our technology. So, please contact us or your local sales rep after the webinar, and we'll be happy to talk in even more detail. So moving on to, the information that's relevant to the title of the presentation, the evolution of compressed gas mixing. Like most successful technologies in our industry, we're continuously looking for ways to improve the BioMix compressed gas mixing system to further enhance our customers' experience. We've been providing high efficiency, low maintenance BioMix compressed gas mixing systems now for over 12 years. And we've learned quite a bit along the way. When I started with Enviromix about 7 years ago, at that time we had about 12 installations. And last year we actually surpassed 120 installations covering 33 individual states. And throughout this experience in all of these installations, we've incorporated feedback from plant operators, consultants, contractors, and also our own field service personnel to incorporate improvements in both form and function of the system. And the next few slides are going to illustrate just 3 examples of the evolution of a BioMix compressed gas mixing. So the first item involves the inclusion of a flow control orifice. As we discussed in a previous slide, all of our stainless steel BioMix headers are factory fabricated, and as part of that fabrication process, we include a flow control orifice that induces head loss to generate uniform distribution of air to each nozzle on an individual header. So this orifice, which is a 1/2-inch orifice, is going to induce about 10 pounds of back pressure, which is going to ensure equal flow distribution to all of the nozzles on a common header during every firing event. The significance here is that we can now configure our system with up to 14 nozzles on a single header. So if you've got a large tank or a long skinny zone or a channel. Whereas in the past, before we started to use the flow control orifice, we would limit the maximum quantity of nozzles on a given header to 7. So including that flow control orifice has allowed us to economize the system, minimize the header supply pipe, minimize the amount of valves, and have a superior solution in large tanks and channels. Compare this to competitive systems that don't utilize any type of flow control orifice. We're generally going to see them applying the technology with only 2 or 4 nozzles on an individual header, which means a whole lot more valves involved in the system. The other main advantage or improvement that's been provided with the flow control orifice is that it provides clearing power. So if you have a facility that's subject to power outages and you end up with solids accumulating, and depending on the hydraulics through the tank, it wouldn't be uncommon if, say, at the end of the tank, if you have a flow baffle, you might see a disproportionate amount of solids settling out in that area of the tank. And when that happens without a flow control orifice, it can become very difficult to clear a single nozzle that may have solids accumulating over it, because air is going to follow the path of least resistance. By including that flow control orifice, now you have the capability to clear a single nozzle that may have had solids accumulate over it during a power outage. Here's an example of the benefits of a flow control orifice. What you're seeing here is a very large equalization tank that's installed at a Midwest airport. The facility actually includes 3 tanks like this. This happens to be the largest compressed gas mixing system in the world. The total combined volume of the 3 tanks is over 100 million gallons, and this tank is massive. It's almost difficult to appreciate the scale on a small video, but to give you some feel for it, the floor of this tank is roughly 300 foot square. It's 30 feet deep with sloped sidewalls, and at the top of the tank, it's over 500 feet square in dimension. And what's really notable, and what we're demonstrating here in this video, is the uniformity of air distribution. Each of these headers that you can see firing is 150 feet long with 12 nozzles. And you can see here in the video that the uniformity is exceptional. The air is coming out of all of those nozzles simultaneously during each firing event. The second improvement that's part of the evolution of compressed gas mixing is called the high intensity mix cycle, otherwise known as HIMC. The high intensity mix cycle is a control algorithm that allows for short periods of very high intensity mixing. Maintaining suspension of biological solids in an actively mixed tank is pretty easy. It's not really heavy duty. You can maintain solids that are already moving around, biological solids, with pretty low energy. And as we discussed, BioMix offers unlimited turn down to adapt to the real-time requirements. On the other hand, resuspending material that's settled to the bottom of the tank after either a power outage or during construction, when oftentimes systems get installed and then they sit stagnant for weeks or months on end, resuspending takes a lot more energy. And if you don't have the capability to introduce more mixing energy, it's either going to take a lot longer to resuspend the settled material, or you may not be able to resuspend it at all, depending on how long it's sat and how long it's compacted. So the high intensity mix cycle is our solution to that. It's set up within our control algorithms, within the master control panel, and it can be set, it can either be enabled or disabled by the operator, and then it can be set to run automatically on whatever interval they may select. They could have it run once a day, once a week, once a month, or they may choose to disable it and simply run it after a power outage. So if they lose power and they have no mixing for a day or 2 days, they can come in and manually run the high intensity mix cycle. And during a high intensity mix cycle, you get about 3 to 4 times the instantaneous energy input. And that's what we're going to show in this video here. You'll see the transition between normal mixing, which includes a header firing roughly every 10 seconds. Going into the high intensity mix cycle, the system will first build pressure to an operator adjustable set point, in this case 90 psi, before all of the valves in that valve module open simultaneously to introduce this surge of mixing energy. And this level of flexibility is very unique to BioMix, and it certainly cannot be achieved with any type of traditional mixing device unless you size those mixers for 3 or 4 times the installed horsepower. The final improvement here that's been critical in the pathway of our evolution of the BioMix compressed gas mixing is the introduction of the zombie valve module. And that's what we're showing here. The zombie valve module is a very straightforward control cabinet that can actually be applied as a standalone solution that offers intuitive control for many smaller applications where you've got a NEMA 4X enclosure that houses all of our valves, and then local adjustment of both the frequency and the duration of mixing right at the panel to make adjustments to the mixing intensity. And again, for a small application, this zombie valve module can be implemented and used on its own. And why this is important is because if you dial back about 5 years ago, our technology probably had some limitations on the lower size limits of wastewater treatment plant. And we just, even though people saw benefits in terms of energy efficiency and no maintenance on the in-tank components, we're a bit too high on the capital cost. And this very straightforward yet elegant solution on the controls allows us the opportunity to bring our technology for smaller facilities that may not have been able to viably use our products in the past. So it's been a big advancement for us. It's opened a lot more opportunities to utilize the technology. And then taking it to the other end of the spectrum, larger facilities, more sophisticated applications, multiple zones or application. These zombie valve modules in an unlimited quantity can be paired with a master control panel now to provide a single point of control, seamless SCADA integration, and optimal control flexibility. And all of the sensitive control hardware, the PLCs, the HMIs that 10 years ago when Enviromix started in the business, or 12 years ago, those were a lot of times included in the field panels. So you had the sunlight beating down on the HMI screens, which of course, led to premature aging of those screens. Now all of that stuff is in the MCP indoor in conditioned space. And in the event of the PLC loss in that master PLC, the zombie's going to have you back. So within each of those zombie valve modules, you have the zombie controller, which is a harsh environment microcontroller, factory programmed for frequency, sequence, and duration of firing. And normally it's not going to do anything but take a heartbeat signal from the main PLC. But if you lose your main PLC for any reason, whether it's a power surge or lightning strike, if that heartbeat signal goes away, then the zombie automatically takes over and initiates mixing with those factory program settings. Once the PLC is restored, the zombie relinquishes control back to the PLC and everything goes on as normal. But as long as you have power to the valve modules, you'll never lose mixing in the tank with the zombie valve module. To wrap things up here, we'd like to review a few case studies, 3 separate facilities that have incorporated BioMix compressed gas mixing to help solve their own unique challenges. The first one is a channel mixing application in Garland, Texas. The Rowlett Creek Wastewater Treatment Plant. It's a 24 million gallon per day facility. The plant has both trickling filters as well as activated sludge. And in their 2018 upgrade, part of that project included modifying and upgraded the RAS channel mixing system. They previously had coarse bubble mixing with positive displacement blowers. There was ample room for improving the system, not only in improving the efficiency, but also just the mixing capability. It was a pretty old system. And like a lot of these, 30+ year coarse bubble aeration systems, you walk down the channel and you see some sections of the channel that are getting absolutely no mixing, and other sections of the channel where it's so turbulent you think the contents of the basin might boil right over the channel. So lots of opportunities here, and BioMix provides substantial advantages in a channel mixing application, very flexible and adaptable to any configuration or depth. The intermittent firing is ideal for channel mixing applications, and because of that intermittent nature, we're able to provide equivalent levels of uniform mixing versus coarse bubble mixing, but with a fraction of the energy input. On top of that, no in-tank maintenance. So there were a lot of opportunities to improve the mixing at this facility and enhance the operating efficiency, but their big challenge was they did not have the flexibility to take this channel off of line for traditional installation. So we actually developed a drop-in system that was suitable for a wet installation. And here you can see a picture of what it looks like. In most applications, in a typical, dry installation standard system, this header pipe up at the top of the tank would be located down at the bottom of the tank. So for the drop-in system, we actually repositioned that header up to the top of the channel. And then at each nozzle location, you have an isolation valve, a piece of flexible hose that connects to a single drop-in style BioMix nozzle that's anchored to about a 70-pound concrete block that then gets lowered down to the channel floor, connected up top, and this yielded a complete wet installation. The channel did not have to come online to install the BioMix system. And because of this flexibility in the design and engineering of the system, we were able to bring energy savings of about 80% to this facility. Since this time, we've worked with other facilities that had similar challenges. They saw great opportunities to improve their efficiency in the channels, but couldn't take them offline. Just recently, we installed over 200 of these drop-in retrievable nozzles at the Simi Valley facility in California. So we're pretty excited about the benefits of this new system. The second case study is a thickened sludge holding application in Broomfield, Colorado. Broomfield thickens both their WAS and their primary sludge prior to their anaerobic digesters. And then in between anaerobic digestion and dewatering, they send that thickened anaerobically digested sludge to two holding tanks. And you see a picture of the floor of one of those holding tanks. They're covered tanks. Round tanks with cone hopper bottoms, roughly 50 feet in diameter, 7 feet deep. Prior to the retrofit with the BioMix system, they had diffused aeration and blowers, and they had a lot of issues. They had hair and rags hanging up on the sharp obtrusions of the supports of that system. And then more importantly, they had issues with solids compacting and settling in the bottom of this cone. And that's a common challenge that you're going to see anytime you try to apply aeration in a hopper bottom tank, because unlike the BioMix system that you see here, with an aeration system, a diffused aeration system, all of the diffusers need to be set at a common elevation because air is coming out of all of those diffusers simultaneously. So in a hopper bottom tank, that diffuser elevation is going to be based on the high point on the outside of the tank, which means in the center of the tank, at the bottom of that cone, you might end up with 5, 6, 7 feet of dead space beneath the aeration grid. And that's inevitably going to result in solids falling out of suspension, accumulating in the tank, loss of volume, and potential odor issues. As you can see here in the picture on the right, with the BioMix system in a hopper bottom tank, we will provide the headers in concentric rings where the nozzles will be installed at varying elevations that conform to the slope of the tank. This ensures complete bottom-up mixing all the way down to the bottom of the cone in that tank. Just like with channels, there are lots of general advantages for mixing sludge holding tanks with the BioMix Compressed Gas Mixing system. First and foremost, it operates with less than half of the energy required for a typical coarse bubble aeration system. It's, of course, adaptable to any tank geometry or configuration, including sloped floors or hopper bottoms. There are no low water level limitations. So in an application like this, where the water level is highly variable and you're drawing the sludge down to the bottom, filling it up, you can continue to get mixing with the BioMix system all the way down to an empty tank. Whereas with a traditional mixing system, either a diffused aeration system or even more so, a traditional mechanical mixer, you get down less than 5 or 6 feet. Your mechanical mixer is now not even submerged. You're getting zero mixing in that application. So the measurable results of the benefits they've achieved at the Broomfield, Colorado facility, they've effectively reduced their energy input by about 50%. The entire mixing for the two tanks is achieved with a duty 20 horsepower compressor drawing about 15 brake horsepower. They've been able to effectively mix up to 6% solids. We talked about the guaranteed performance. We ran the witness performance testing here, and we were able to demonstrate less than a 5% coefficient of variation amongst total suspended solids, even up at 6% solids. And then most importantly, they're getting better mixing. They've eliminated the issues with solids settling in the bottom of those tanks. And since the tanks were covered, they eliminated all of the issues with confined space entrance that they had when they had to do maintenance on the previous system. The final case study here is going to be a case study of a plant that's utilized BioMix for mixing their B&R selector zones, Emporia, Kansas. Emporia, Kansas was upgraded in 2019. It included both improving the process to facilitate biological nutrient removal, as well as increasing the flow capacity from 4 MGD to almost 5.5 MGD. They went with an integrated fixed film activated sludge, IFAS type process, so that they could fit within the existing basin volume. And what you're seeing here in the picture is the byproduct of that, fitting into these existing basins. Since they weren't starting from scratch, they ended up with some kind of irregular zones that would be pretty problematic for traditional mechanical mixing. Anytime you end up with a very long, skinny zone, it's very problematic for that type of mixing device. You end up having to put in a whole lot more mixers. A traditional point source mixer is most well suited for either a square or a circular tank. So here's another example where you could see the flexibility of configuring the BioMix system. So anytime you have irregular basin geometry, such as long skinny tanks or obstructions, it's really well suited for BioMix. Lots of advantages in a B&R selector application. And at the Emporia facility, the BioMix is installed in the anaerobic zones, anoxic zones, swing zones, and then also the deoxygenation tanks. So this is an example of the power of applying BioMix compressed gas mixing when you have a lot of different zones to mix. Because with traditional mixing devices, a lot of different zones means a lot of different mixers, which means access walkways to all of those mixers, platforms and removal mechanisms, hoists and rails to get them in and out. None of that ancillary supporting equipment is required with BioMix. On top of those advantages, we'll offer 50 to 60% energy savings and no maintenance in the tank. So the key takeaways here on Emporia, with the mechanical mixers, they were looking at having to install at least 16 mixers, including a whole bunch of access walkways and platforms to allow those mixers to be installed and removed for maintenance. With BioMix, all of those walkways and platforms went away, and they achieve all of the mixing in all of those zones with a duty and a standby compressor. So that duty and standby compressor replaced the maintenance on the 16 mixers that they would have had. They're much more accessible. They're in a heated building, so a lot easier to access and maintain. And at the end of the day, they're achieving roughly $50,000 annual savings in operation and maintenance. So that will take us to the end of the presentation. I was only a couple minutes over the allotted time. So we will now go through and hopefully address some of the questions that have come up. So the first one is, where is the orifice located with respect to the nozzle? And as we showed in that picture, I'll actually go back to it so you can see it. That orifice is going to be right at the outlet. So here you can see when it's clamped in the vise here, at each outlet, you've got a half coupling welded to the pipe, and that orifice is going to be drilled into the pipe right at that point. Next question here. Do large bubbles increase odor release? That's a great question, and that's a question that we get fairly often. It actually does not. We're putting in such a low volume of air. You know, if you recall some of the videos, it's not the turbulent type mixing pattern that you're going to see typical of a coarse bubble aeration. In fact, the agitation at the surface isn't that much greater than you'll see with a lot of traditional mixing devices. So the agitation alone isn't going to do it. The amount of air, the volume we utilize to completely mix a tank with the BioMix compressed gas mixing is extremely negligible. So a great example would be to compare it to coarse bubble aeration, which is often used as a mixing device. So if you were to look at an equalization basin type application or a septage receiving, it would be pretty commonplace to size the coarse bubble mixing system on a volumetric air rate of, say, 10 SCFM per 1,000 cubic feet. And on that basis, to achieve the mixing with BioMix, we'd be using about 8 times less air. So really no issues with increasing the odors with the BioMix system. Next question. What kind of noise does the air compressor produce, and would a nearby homeowner notice it if it was outdoors and under a canopy? Another good question and a pretty common one. We work with a range of compressor manufacturers. We're not married to any specific compressor manufacturer, so we have experience with most of the major manufacturers in the US, and almost all of them package their compressors standard with a sound attenuating enclosure. So these compressors are actually pretty quiet. Typically, they're going to be less than 70 decibels, probably to be exact, about 68 decibels. And you can easily stand by a machine running at 68 decibels and have a regular conversation. So noise is not very, very significant at all. Another question here. Mixing applications within anaerobic digesters. Can we do it? Yes, we can. We can effectively mix anaerobic digesters. The mechanisms for mixing, the in-tank equipment, the nozzles are the same. It's configured in a similar fashion. Most anaerobic digesters, at least I would say all of them that we've come across, they're traditionally going to have a hopper bottom. So I'm going to bounce right back to this picture here. So just like you're seeing here, in a lot of cases with an anaerobic digester, it's even more significant. In fact, we have an installation for the city of Atlanta at the South River plant in 2 of their primary digesters where there's a 10-foot cone at the bottom of each tank. So it becomes very advantageous to form the headers in concentric circles. The big differentiator between the mixing applications, in the open top tanks versus the anaerobic digester is going to be the gas source. So instead of using air, we're gonna use a specialized compressor that's suitable for biogas, and we'll pull the biogas from the headspace of the anaerobic digester, and then with minimal conditioning, basically just a moisture pot to knock out, the hydrogen sulfides and some of the bad things in that biogas. That'll get knocked out. We'll compress the biogas and then form bubbles from the bottom of the tank up with the biogas to provide very efficient mixing. Moving on to another question here. How do we keep solids from getting into the nozzle air header when there is no flow? It's another great question. So each time we have a firing event, and I'm going to go to something that shows the valve module. So each time there's a firing event, this spool valve within the zombie valve module is going to open. They're all normally closed. And the valve manifold sitting behind those valves is pressurized at 100 psi. During a firing event, one of those valves will open, facilitating this massive rush of air down through the header, out all of the nozzles. After that firing event, which is typically somewhere between a half a second and a full second, that valve closes. And when that valve closes, the seal seats and it provides an airtight seal within the valve. It traps air in the pipe leading out to the nozzle, producing an airlock. So it's like putting your thumb over a straw in your cup of water. It prevents backflow through the nozzle. One more question here. What are the standard maintenance requirements for how often the nozzles should be inspected? Another good question. With the system, there's no scheduled or preventative maintenance on the in-tank equipment. So the short answer is never. The real practical answer is, just like a lot of equipment that is very low maintenance, part of that is dependent on appropriate installation. So typical and reasonable guidelines would be you install the system, or the contractor at your facility installs the system. We'll have our field technicians come out and do a walkthrough, ensure that everything was installed correctly, start the system up. Anytime you're dealing with a system that has, joints beneath the surface, a lot of, nuts and bolts, you go back in. The first time you're going to take your tank down to clean it or inspect other equipment, it would be a good idea to do a walkthrough. Aside from that, there's no regular maintenance that you need to plan for on the in-tank equipment. So again, thanks everyone for joining. We really appreciate the opportunity. I think there's going to be some type of a survey that you're going to be receiving, and also a certificate of completion. If anyone has applications they would like to talk more about, we'd love to hear from you. Either reach out to us directly through the website, or if you have our contact information. If not, I'm sure you know your local reps, and we'd love to hear from you through them as well. So until next time, thanks again for joining, and we'll look forward to seeing you on the next series of our webinars. Have a great day.